Okay, so this is the granddaddy problem. This is 4.5, page 199 in the textbook. And so this is one I expect a lot of people will want to watch the video on. Let me first tell you what the objective is, and thereby sort of reviewing what we did the other day with these plots. Okay, so the blue plots, the black plot is just C. This is your curve C, and this is exactly the curve that we're going to be plotting in the granddaddy problem. Okay, now the dark blue, the slope of these guys is average cost. Okay, so C is a curve for cost, and remember average cost is C divided by Q. So if you take any point, say in this plot number 4, you take this plot, this point is Q comma C of Q. Right? And how do you calculate this? Well, it's just the line between the origin and this point happens to have the same formula that we have over here, because if you say minus 0 on top and bottom, it's the same, right? You can take a fraction and subtract 0 from the top and bottom, and then that is the slope of this line. So there's two ways to look at this. You can think average cost is total, cost divided by per item. That tells you the cost per item. That's true. But it can be interpreted geographically as the slope of this line. And that's how we're going to make use of that. And then the other thing you're looking at is your good old C prime. Slope is C prime. So these guys are the tangent lines. Okay, and you can see the progression. I might be able to make an animation of this, but I'm not sure. It would take a lot of time, so don't hold your breath. Okay, but see, I want to take this tangent line and I keep moving it along as I go along, as I go along. But you see, there's exactly one magical place right here where the tangent line coincides with the average cost. And that's the magic place where, okay, we have average cost is minimized at this Q value. Okay? And that's the whole point about that flexagon, is to get this point across. That we have two separate, as this point moves along the curve, this red point, or whatever color point it is, this red point keeps moving along the curve, alright? And you draw two lines coming out of that point, one of which is a tangent line, that's the light blue line. And the other line is a line that just goes back to the origin from that point. When those two lines coincide, that's that magic point. Okay, and then we will also have another plot as we develop this the answer to this question. We'll develop another series of plots that is two parabolas, one on top of the other. Okay, and that's the other graphical interpretation. So the first thing we want to do is, we can't use quick plots because, actually we talked about this briefly in class, but I'll just mention this again. Okay, you have cubics that look like this. These cubics have a max, a min, and a point of inflection, and the point of inflection happens right between the max and the min. It's either max, point of inflection min, or min, point of inflection max, but it's right in the middle. And another kind of cubic you can have is, you can have just flat, okay, and it can curve in either direction. This cubic has point of inflection, but it's a critical point. It's a critical point because f prime equals 0 there, and f double prime equals 0 there. You see, in the previous example we have f prime is equal to 0 just on the max and the min, but not on the point of inflection. At the point of inflection, f double prime equals 0. Okay, but for these guys, f prime equals 0. But when all those three things come together, you get a horizontal tangent line and you get a point of inflection occurring at the same time. That's another kind of cubic. And finally, you can have a cubic where you're just going strictly up or strictly down, like this. And they're still symmetric, but these little blue lines disappear. no maxes and mins. But you have to have a point of inflection. Okay? And so these cubics have just a point of inflection. So y double prime equals 0 there. But if you try to set y prime equals 0, you get complex roots. So if you try, just as a special, just cubics, this only works for cubics. But cubics is most of what we deal with in this class, so this is important stuff. Okay, there we go. Now, back to our question, we're going to graph C. Okay, so we're already thinking, well, it can't be one of these downward facing cases. This is not going to be that. And so it's going to be one of these three. Because it's an economics problem, we're going to guess this is going to happen, or possibly this guy. But we have to go ahead and go through and see what's happening. So the first thing you might want to do is if you factor out a q, you will find, for part A, if you factor out a q, you will see q squared minus 6q plus 15. That is c. And so you see there's a root here. Okay, but we don't know about this other stuff, and we attempt to factor it and we fail, and we try to use the quadratic formula. Well, the remaining roots are going to be q is equal to negative b, so here is b in the quadratic formula, right? So it's negative b plus or minus the square root b squared minus 4ac all over 2a. And you don't even have to calculate this, you just look at the mess inside the discriminant and you say, oh, this is why we're having trouble factoring it. It's 36 minus 60 is negative. You don't have to go any further than that, and you just say these guys are complex roots inside. Okay, so that means we're going to have to try something else. Okay, so the quick plot, we'd love to use it, it's not going to work. Right. So we're going to try something else. We're going to just try to use calculus. Okay? Now let me make a point. Just because we got complex roots does not guarantee that we don't have this situation, because we could just have, this is the axis down here, this is the x-axis, and you see there's only one root and there's two complex roots. But you could also have this thing going on. Either one of these or flat, any of those three cases, we still haven't eliminated much. We just know that we can't use quick plot. Okay, so let's continue. So we go ahead and go back to this form of the equation, because it's very hard to take the derivative when the thing is factored. We take the derivative this way. You guys all know how to do that. And set it equal to 0. We can get rid of those 3's because obviously 3 is not equal to 0, so we can divide both sides by 3. 0 divided by 3, so is still 0, right? So, and again, we wish this factored, but it doesn't. However, these guys have complex roots. We did this in class, so again, we'll try q is equal to negative b plus or minus square root b squared minus 4ac all over 2a, and then you say, aha, negative. So we have complex roots. Alright, so we don't have to continue this process. We don't have to look for the roots. We just know they're complex. So this is other type of cubic. Pi only cubic. Right? Right, so let's figure out where it is. Alright, so we have to go back to this, right? Because when we divided by 3, we were just solving for equals to 0. So let's go back to our actual C prime and calculate C double prime. Alright, so then you can see that Q equals 2 is our root, and that's the point of inflection for C. Alright, now we want to know where it is. C of 2 is equal to what? Well, you got to go all the way back up to where we found out. What was C? Alright, so let's go ahead and copy this. put it down here. Alright, but every time you see a Q, I want to put a 2. Get rid of the Q and put a 2. Alright, so we have 8. 6 times 4. 24. 30. Let's be lazy. Alright, so 8 minus 24 plus 30. Okay. So we can plot this now. We know that this point of inflection occurs at 2:14. And this occurs, the root occurs at 0, 0. And the question says, estimate minimum value of A. Okay, well, it's going to be somewhere beyond 2. So this is where that blue line and the light blue line and the dark blue line have to be coinciding somewhere over there. Okay, and so that's going to be somewhere around 2.5, maybe 3 is probably where we're going to see that occur. Okay, and it's going to be a little higher than 14, so if this C value is 14, maybe this point is 2.5 and 16. That's my estimate. I have no idea, right? I'm just guessing. But that's what the question asked me to do. It asked me to guess. Alright, so now we want to graph A, and then we're going to do those other pieces. Okay. B graph A. Well, what is A? Well, A is C over Q. Alright, so we go ahead and do that. And so A is Q squared minus 6Q plus 15. And too bad it doesn't factor. Okay, well, then we go ahead and find the roots if we can. And we're going to say Q is equal to negative B plus or minus square root B squared minus 4A C over 2A, and we end up with the same thing, complex roots. Okay, so all we need to do is find the vertex, because if we can't find the roots, we may as well use the vertex. It's a parabola, it shouldn't be so hard to plot. Well, you see minus B over 2A is where the vertex is. We already actually calculated that right here, but let's pretend we didn't notice that. Okay, so minus B over 2A is equal to 3. The vertex is at 3, and so A of 3 is 3 squared minus 6 times 3 plus 15 is 9 minus 18 plus 15. 9 minus 18 plus 15 is 6. Okay, so what did it say for us to do? We had to graph A and estimate where A is a min. Well, we know where A is a min. Sorry about that. Okay, so at 2, 3, 6 is the vertex of A. So 1, 2, 3, 1, 2, 3. I'm gonna have to put 15 all the way up here. So I'm gonna put 6 somewhere down here. Okay. Point. It's much easier to draw on your chalkboard. There we go. There we go. Alright, so that's about roughly what I want to show you. Okay, so that's A, and so I estimated the cost, the total cost. So I did this problem incorrectly. So estimate of total cost what it had asked me to do is estimate the average cost. So the estimate of the average cost, let me see, I'm doing it for the wrong point now. Okay, I want to estimate the average cost based on my estimate of the total cost. Sorry about that. There we go. Okay, so estimate of the average cost is total cost over 2.5. What is that? 16 over 2.5. There's something like 6.4. Okay, so I would go back and fix that problem. But see, now I'm seeing this and I'm saying, aha, so the actual is 3.6. That's why I went back and said, oh, my estimate was way off because I forgot to divide. Now my estimate is closer than when I estimated just with the 16, because obviously I was just estimating the cost, not the average cost. Okay? Hopefully that makes sense. Okay. So this is the actual quantity which minimizes average cost and the actual average cost, which is a minimum. Okay? And so that is actually answering part C. So now we have to ask part D, which is graph marginal cost with average cost. Okay, so if you've done this before, you'll get used to this. So you need to practice. But both marginal cost and average cost have the same intercept. Let's take this again. We had C prime. Okay, so I'm going to just grab it out of this part of the problem. I am going to come down here. So we know what C prime is, and we want to know what average cost is. And we're just going to grab it out of this part of the problem. Okay, so we have these two pieces of the problem, and you notice the way these problems are constructed, and yours will be the same way too. Okay, these guys always have to be the same, and these guys always have to be a parabola. So if you take a cubic, like we started with the original problem up here, we started with a cubic that had no plus c on the end. And that means when you divide off by q, you're guaranteed to get a parabola. And also when you take a derivative, you're guaranteed to get a parabola, but specifically this term here, if you take the derivative of 15q, it's 15. But if you divide 15q by q, it's also 15. So it's not a big surprise when we come down here, we find out these guys have to be the same. These guys have to have the same y-intercept. So that's not a shock. Now, we already found for A that A has a vertex at 3, 6. Okay? 3, 6 is the vertex of A. Okay? And we may as well calculate the vertex of C prime. So minus b over 2a, we want to find the vertex so we can plot this guy, is minus b over 2a is at 2. So at q equals 2, this guy has a vertex, and we would like to know what's c prime of 2. Well, 3 times 2 squared minus 12 times 2 plus 15. Let's pull out the calculator. 3 times 4 minus 24 plus 15. And that is equal to 3. So 2, 3 is the vertex of that other guy. So let's put all these pieces together. Okay, so we have, if this is 15, let's see, this is probably 10, 5, something like that. Right? And so we want a vertex for A at 3, so maybe this is 3. And let's put 6 over here. 3, 6. If that's the case, then this is where 12 is. There's got to be a 15 over here. When you have a vertex of a parabola, you know that the parabola is symmetric about the vertex, and you have one other point. That's enough information to plot this guy. There we go. Maybe dotted lines are easier to draw on the computer. Okay. So this is A. Then we have a question we want to put 2, 3 is the vertex of the other guy. Alright, so this is about 2, 3 is the vertex of the other guy. Ah. I am sorry, I messed up the plot. I really apologize for that. And I know you will do the same thing. And that's okay. It's alright to mess up. But I still apologize. Okay, 1, 2, 3, 4, 5. So I want A to have a vertex at 3, 6, and I just didn't do a good job plotting that. Okay? So 6, 15 would be the other point. So I'm going to try this again. Okay. So this is going to be A, and this vertex is 3, 6. Alright. Now I'm going to plot the other one at, the other vertex is at 2, 3. There we go. And you could say, well, there's got to be at 4, this guy has to go up to 15. But make sure you don't accidentally forget this really important thing. Alright. What's the really important thing? This is the really important thing. This is marginal cost. Marginal cost equals average cost when average cost is minimized. And average cost is minimized there. Yes? I'm going to erase this ugly circle. I'm going to draw this a little bit bigger. I don't know if this will help at all. But I want you to see where the vertex of A is. Marginal cost has to cut through there. Okay? And that may take a while, but that's what you need to do. You just, you know, the same problem, you'll be able to do that if it's an exam or a final, and it would, the numbers would be tweaked, but the same pictures would show up. You'd still end up with these interlaced parabolas, so you can just put those little parabolas on your cheat sheet if you want, as a way of reminding you that that's the way they're always going to look. The only difference is where this guy occurs and where this guy occurs and where those 3 points are the 3 important points. You need to figure out where they are so you can make a nice plot, but other than that, your plot is going to look the same. It's going to be exactly the same, and you're going to still end up with your cost function that looks like that. Okay? So I'm going to just stop the video here. Hopefully that is helpful to some people.